Storage queuing is a pretty simple message queuing system, and it's really designed to provide a couple things. As I said, simplicity of operations, also the ability to have multiple consumers access the same message. And that's a fundamental really distinction in the approach to queuing that's provided by storage queues. And we'll actually look at that as opposed to another type of queuing in just a few minutes. All right, so what are some of the key things that we have to provide this very simple and potentially multi-access architecture for queuing? Right? First of all, you've got certain operations within a storage queue. You have the ability to peek at the next message. So you can see the next message without actually officially interacting with it. You can dequeue the next message, so you can pop a message off of the queue. You can insert a message, obviously. All right, you can also, it's not listed here, but it should be. You can update a message. It's listed down below, but I think that's a primary function. And you can check the last cached message count. So how many messages have been cached and are in the system. Now, this is fundamental to the architecture. With storage queuing, message content is stored as a string. Okay? So effectively, if you have anything that can be serialized to a string, as long as it's not too large, and we'll talk about that in a bit, then it can be stored in a storage queue. It'll have to be serialized. If you've got objects you want to store, you'd have to serialize them into strings and then deserialize them back when you wanted to use them. Okay? Now, the message content is or can be updated to provide, as I said, a concept of state, right? So I can, in a typical queue, in most queues, you pop a message onto the queue, or you push a message onto the queue, and then you pop that message off one-time use. And we do have a queue structure that does that, right? But this is more, I can pop a message onto a queue, it's an object in the queue, and then it can be accessed potentially multiple times by different consumers of the queue. Okay, now, the result of a message should be idempotent. Now, what does that mean? Okay, it means there's a possibility of reprocessing a queue message, and that should never be detrimental. So there's certain things that this would not work well for. For example, if I had a system that was a purchasing system, and every time somebody placed a purchase, maybe through a point of sale system or possibly over the web, right, maybe you want to generate a message so that it can be processed, right? But you would, in the case of a purchase, you would never want that to be processed more than once, right? Because then somebody's going to be charged multiple times, they're going to get multiple copies of something that they may not necessarily want multiple copies of. So that would not be a good candidate for this type of queue, right? Maybe a good candidate for the other type of queue we're going to talk about. However, let's say that you've got, yes, I'm going to use this example again, an image processing system, right? And people upload images, and one of the things that you need to do is you need to process a watermark for each image and make a watermark copy of the image. Well, if you were to process that more than once, there would be some performance issues there, but it wouldn't really have a negative impact on the overall architecture of your system. And that's really what we mean by idempotent, is that it is something that can be reprocessed without any real harm to the underlying data system that you're working with.